All right, this is for regular stats, lesson 11.3a, inferences concerning the difference between two population or treatment proportions. All right, so we've already done a two-sample t-test, a paired t-test, and it was all about means on those last few lessons. Now we're diving into when we have proportions, and we have two samples, and we're comparing proportions. All right, so we are doing a two proportion Z interval today. All right, so for confidence intervals, the first step is to check your conditions. So the first condition we want to check is, like always, random samples. But in this case, because we have two samples, we want to make sure that both samples are random. All right, so that is our first condition, which is both samples are random. Or you can just write random samples with an S. All right, and that is our first condition. Our second condition, typically for proportion, is to check if NP and NQ are both greater than or equal to 10. Now, since we have two samples, we want to check NP and Q for both samples. All right, so we're going to end up with 4 numbers at the end. So we want to check if NP hat and Q hat for sample number 1 is greater than or equal to 10, and also NP hat and Q hat for our second group is also greater than or equal to 10. All right, so we just want to make sure that all 4 of those numbers are greater than or equal to 10. All right, and then our last condition to check is similar to our two-sample t-test, which is just to make sure that the groups are independent. All right, so groups, are independent. Or samples are independent is great too. Independent. Okay, so once all 3 conditions are met, we will use a normal model. Since we are doing proportions, we're back to normal model. So I will use a normal model to do a 2-prop Z int. To do a 2-prop Z int. All right, and that is our statement. Okay. Next up is to do calculations. So then that's the formula. That's what your calculator will be doing for you. And if you notice, again, we have 2 groups. And so we have the difference in the proportions, plus or minus the critical value, depending on what % confidence level we want, times the standard error. All right, and then once we get that confidence interval, we'll interpret it, and that is it. All right, so let's go ahead and try this first example. Okay, so it says, the article Freedom of What? Described a study in which high school students and high school teachers were asked whether they agreed with the following statement: students should be allowed to report controversial issues in their student newspapers without the approval of school authorities. It was reported that 58% of students surveyed and 39% of teachers surveyed agreed with the statement. The 2 samples, 10,000 high school students and 8,000 high school teachers, were selected from schools across the country. Compute and interpret a 90% confidence interval for the difference in proportion of students who agreed with the statement and the proportion of teachers who agreed with that statement. All right, so already kind of reading through that, I want to underline a few things. So 90% confidence for the difference in proportion of students who agreed versus the proportion of teachers who agreed. We have 2 samples. All right, 10,000 students, 8,000 high school teachers, 58% of students said yes, 39% of teachers said yes. All right, let's go ahead and let's start with our conditions. All right, so the first condition we want to check is random sample. And so in this case, I believe it said, oh no, it doesn't say. So we'll just assume. All right, so conditions. First one, we're going to assume random samples. All right. And the second one we want to check is the NP and Qs. All right, so let's start with students. So 58% of the students said yes. So if I do 0.58 times 10,000, I get 5,800 students said yes. So that is my NP hat for students. And then if I do the same, but instead for students who said no, I know that 42% of students said no. All right, so the complement of 58%. So 100 minus 58 is 42. So 42% times 10,000 gets me 4,200 students said no. All right, so that's my NP hat and Q hat for students. And then I do the same for teachers. So 39% times the 8,000 high school teachers gets me 3,120. And then the complement of 39 is 61. So 61% times 8,000 gets me 4,880. All right, and just all four of those numbers are greater than or equal to 10. And that's all you have to show for that condition. Okay, so next, our last condition is we're going to assume that the groups are independent. All right, so assume the groups are independent, that the students are influencing the teachers and the teachers are influencing the students. Okay, so that is step one. Those are our conditions. Okay, step two, we're going to go and make our statement that I will use a normal model to do a 2-prop z int. 2-prop z int. Okay. And next we're going to go ahead and do that calculation. So go to your calculators, go to Stat, Tests, and then find that 2-prop z int. And that should be letter B. All right, letter B, 2-prop z int. And then go ahead and type in, for your x1, that's how many students said yes. So we actually already found that here with the 5,800, so that will be your x1. I'll go ahead and write this down here so you can see what I'm seeing on my screen. So x1 will be 5,800, n is the 10,000. Your x2 is how many teachers said yes, and we already found that here at 3,120. And then your n2 is the 8,000. All right, and then your confidence level is going to be that 90% from the problem up there. All right, 0.90, excuse me. All right, and then press calculate. And the interval I get is 0.1779 to 0.2021. All right, 0.1779 to 0.2021. All right, so you only have to write down this part. You do not need to write down that part. Okay. So our last step is just to interpret what that means. So we start with, I am 90% confident that the interval from 0.178, I'll go around to the third decimal, to 0.202, okay, captures the true difference between the proportion of students who agree with the statement and the proportion of teachers who agree. All right, so basically the key things you want to have are that you're 90% confident that the interval from blank to blank captures the true difference between the proportion of your first group and the proportion of your second group. Now make sure the order is consistent. So when we did our calculations, right, X1 and N1 represented students. So in my statement, I start with talking about the proportion of students, and then I talk about the proportion of teachers. All right, so the general guideline would be I am blank % confident that the interval from blank to blank captures the true difference between the proportion of blank, group 1, and the proportion of blank, your second group. All right, so that is how you do it.